Hello everyone, so you might have heard of recursive descent parsing algorithm, and there's a whole bunch of theory behind it, but in this video I'd like to explain this by implementing a very simple integer expression evaluator in Go programming language. So if you want something more high level, like in Python for instance, although the algorithm is fairly the same, you can reference my programming a basic programming language interpreter in Python series where the expression evaluation is covered like as the part of that tutorial. That there's a single video, so there would be a link in the description down below this video. Well, okay, so without further ado, let's actually get started. So I just want to create a new directory and let's call it expression, and then just go in there. I want to initialize the new Go module, so go mod init, call it expression, okay, and it creates the module. Great. So now let's create a new file called expression.go and add expression go, and I just want to add some syntax highlight in here, lexer go, and here we go. So I want to type the following thing here. So this is going to be expression evaluator, okay, and this is going to be a package main, right? So I also want to import some packages here, so import fmt, so that I would be able to print strings to the standard output, and also I want to import strings. We'll also need string convert, but yeah, since I want to run this first and avoid having errors like the module has been imported and yet not used, not going to be importing this just for now. And I also want to define one single global variable called token. So this is going to be the next token to pass. So variable token is the type of string, okay. And finally, so main bar here, so func main, and let's just say fmt print line, and let's say expression. We don't yet have an expression, but we'll now provide one, so let's call it line, okay. And all right, so yeah, I just want to say let's say line equals to, and then say 12 plus, let's say 4, okay. Yeah, so let's try to run this. So I want to say go build, and if it builds, run the expression binary executable, okay. Undefined line, yeah, that's because strings is not used yet. Yeah, but yeah, that's fairly enough because they didn't really yet use the strings. So line 13, okay. Yeah, so strings important and are not used yet, but yeah, well, that's because I didn't really yet use them. But anyway, yeah, let's probably first just say 6. Okay, just comments it out. Okay, so we got our expression being printed here. Now let's implement the routine called scan. So it's going to initialize our global token variable with the next token. So tokens in the expression might be either numbers or operators, or also this might be like parentheses. but parentheses are working pretty much like operators. So just right above the main, so let's say in the line number 10, so want to create a function to get next token, and this is going to be func scan. It takes the line, the string type, and also I, which is the pointer to integer. Now this I is really interesting because this is the index. We are updating, like incrementing from the very beginning of the string and up to the very end, and by the time we increment this index, we actually do sort of eat our string like token by token, and then based on what token that is, we take a certain decision whether to add numbers or to multiply or to process parenthesis or the unary minus, for instance. So a whole lot of things, but that's going to be covered a little bit later. But for now, we just need to distinguish between two essential types of tokens, which are the number and anything else but the number. So, but before that, I just want to make sure that if the value of our index pointing to the certain character within the string, so the one we are now processing, if it's greater or equals than the length of the line itself, this case we just want to return, because otherwise it would give us an error. So hopefully that makes sense. Now if line is digit, if line index by the index is greater or equals than the character 0, and line index by the index is less than character 9. So in this case, we know that we are within the parsing digit territory. So in this case, I would just want to say token equals to, and I just call the number function, passing the line and pointer to our index I. So it's not the index itself, it's the pointer. That's essential. It's very important, because we're supposed to be altering, like literally incrementing this I variable in the nested functions, and in the upper level functions the value of E is going to be changed as well. So it's really important to send exactly the pointer to the I and not the I itself, because otherwise the string is not going to be like progressing through the tokens. So that's quite important. And otherwise, I want to say else if, and you can say string star contains. And now if we do match the operator like plus, minus, multiply, divide, and parentheses, and if we just want to stringify whatever goes with line index by this, the value of I. So in this case, what we want to do, we just want to say that the token is going to be equal to operator, and again sending the line and pointer to the I, which is line index. Okay, let's have a look what we got here. Okay, so to make it work, first we need to uncomment the import string. So 6, I just want to substitute the like this. Okay, so uncommenting strings, and now 20, just want to add one more line there. And let's try to run. So it should give an error that we don't yet have the number and the operator, and no other errors, which is absolutely amazing. Okay, so let's say right above the scan, so let's say 11 insert, let's implement the function to parse the operator. Okay, so say func operator takes line, that's the string type, and I is the pointer to the integer, and it returns a string, which is quite important. So all I need to say here is that operator is equal to whatever goes line index by the value of I, and then we want to increment the index that is pointing to the next character within the string, and finally we just want to return operator like this. And next I want to create a function to pass the number, right? So function number, and again takes the line, that's the string type, I, that's the pointer to the integer, and it also returns a string. So this string would later be converted to the actual integer, but for now we just return the string because that's the token and not the actual number, just the token. So I just define our num variable here. It's going to be an empty string for now. And now we have a loop. So for like we need to make sure that the index is less than the length of the line, otherwise there would be an overflow. And also we want to make sure that the line indexed by our index is digit, so it's greater or equals than 0, and line is less equals than 9. So in this case we do match a digit. So in this case we simply want to say num plus equals, and now we stringify whatever goes within line indexed by index. Okay, so after the same we just increment the index, and eventually we just return num. Yeah, let's have a look what we got here. Right, so it's actually look from the very beginning like this. Okay, parse operator. Okay, and let's say 11:30, and the pass number. Yeah, it looks fine. So let's save this and try to build. Okay, type byte a string in return argument. Yeah, obviously. So in line 13, yeah, so actually messed up a little bit. So I'm going to say operator equals, I want to stringify whatever goes with line indexed by the index, yeah, because otherwise it just returns the runtime. It's not a string, it's actually the byte, I guess. Yeah, so let's try again. Cannot assign to operator. Okay, and now it can pass. Okay, so now let's actually test whatever we got here. So I just want to say that I want to scan and the line and pass in the address of the I. Alright, and I want to say fmt.print line, and so just printing the token, whatever is the token variable equal to, whatever token variable equals to. Right, so I want to do this actually 3 times. So the idea is very simple. So we just scan through the next token, so the token should be initialized to 12, then we'll do exactly the same thing, and the token should be equal to plus, and then we'll do it one more time, or last time, and the token should be equal to 4. So let me just quickly paste this, and yeah, every time, yeah, literally doing the same thing 3 times. So it now should print the token and the respective value. Okay, undefined I. Oh, that's because I didn't actually define the index. So let's say 40 and I equals to 0. So it's very simple. So line indexed by 0 is 1, line indexed by 1 is 2, line indexed by 2 is plus, line indexed by 3 is 4. So hopefully this makes sense. Very simple stuff here. So I just want to right quit and run this again. Let's have a look. Yeah, so we have the first token, so it's 12, which is good, then our token plus, and then token full. Okay, great, so now let's implement the function that would get the factor. Okay, so here we want to create a function to pass the factor. So you'll now hopefully understand what the factor is. So func factor, and again it just takes the line, and that's the string type. It also takes I, which is the pointer to integer, and it returns integer, which is quite important. So I just want to define the num variable, which is going to be equal to 0. So integer type will eventually return this num. So it might happen that our token holds either the number or the operator. So how to distinguish between these two? So I can simply say if, and then the token, and the very first element of the token is greater or equals than 0 character, and token indexed by 0 is less equals than 9. In this case, we are sure that the token indeed holds a digit 4, otherwise it would be just holding the operator value. Okay, so in this case, I just want to say num, and it's going to be equal to string convert, and I want to convert the string to the integer and the token itself. That's pretty much all about it. Now, just to make sure it works, we need to also import the string convert, but yeah, we'll do this just in a moment. So also I say else if, and it also might happen that the token is equal to the opening parenthesis. This also might be the case. So in this case, what we want to do is the following. We just want to scan through the opening parenthesis, and again line, and pointer to the integer, right? Pointer to the index. Then we want to evaluate the number. So we say expression. So this is the evaluation of the sub expressions. We have some in the parentheses that should be evaluated like as the sub expression. We don't yet have the expression function. We'll provide this a little bit later, but for now we just want to pass the line and the pointer to the index, right? Then we need to make sure that the token is going to be called the closing parenthesis. And yeah, obviously I'm not doing error handling here, and this program, since it's just a didactic tutorial, it assumes that there should be like normal expressions, like without malform, like malformed expressions are not going to work. So just for the sake of simplicity and to save you time, because I don't really want this tutorial to last forever, I just omit the error handling here. So we suppose that the parentheses, opening and closing parentheses, match each other. So hopefully that makes sense. So actually in this case, we just want to return our num. Okay. Right. And finally, it might happen that token is equal to the unary minus. And in this case, we just scan through the unary minus, passing the line, the I, and we just want to return minus factor. So recursively calling the factor with the same parameters. And finally, we just want to return the number. So that's from the very first case. If we did match the number. Yeah. So let's have a look. Yeah, now let's see if it still works. Yeah, probably it shouldn't compile because we don't have the expression yet, and we don't have the string convert. So let's add those as well. So I want to say import string convert. Okay. And we get our string convert. And also let's just drop the expression function. We don't yet have it, but yeah. So I can say 11 append and want to pass expression, the function to pass the entire expression. So we'll come to this a bit later, but now for now just say func expression, line the string, and I is pointed to integer, and it returns the integer. Let's just return 0 for now to avoid any errors. And let's have a look. Yeah, great. So yeah, so the output is still the same because we didn't yet quite do anything. So now let's try to test our factor function. So how we can do this, let's do the following way. So for instance, say 68, 69, I just want to say format print line. So we just scan through the very first element, so now token is equal to 12, and then we just want to print the factor, and I say factor and send the line and the address of the I variable. Okay, yes, we got it, and now it should print the factor equals to 10, but this time, well, token 12 is equal to 12, sorry, so token 12 is the string type, while the factor value of 12 is the integer because we've converted this. So this just ensures that our string to integer conversion is working properly. Okay, now the very heart of the evaluation itself. So we'll now create two more functions, well actually one more function to parse the term, and parse expression is going to be like almost exactly like the parse the term, just a little bit different operators being involved. So let's go and just right above parse factor, so say 17, append, and so want to write the function to parse the term. So term operates on factors, so literally this is about to be holding multiplication and division. So hopefully that makes sense. So I can say func term, and it takes the line, which is the string type, it takes the I index, which is the pointer to the integer, it returns the integer, and here we are dealing with exactly two numbers. So let's define num1, and this is going to be equal to whatever factor is. So line and pointer to I, right? Now we are entering a loop. So the first thing to do is scan through the next element. So this is important. And after we did scan through the next element, we want to ask what the token is actually equals to. So we can say if token is equal to multiplication. So first we handle multiplication and division, and then addition and subtraction. So hopefully that makes sense. So parse term exactly deals with this particular multiplication. So if we did encounter the multiplication, first we need to scan through this token. So scan again, line I, okay. Then we calculate the second number. So after these multiplication sign, they're assumed to be a number. Well, obviously it might not be there, but again, we omit the error handling for the sake of clarity and simplicity. So num2 is going to be equal to factor, line and I. And finally, I want to say num1 equals to num1 multiplied by num2. Okay, and here say else if and token is equal to divide. In this case, fairly similar thing here. We also scan through the division token. We do extract the num2 exactly the same way. So we say factor and line and I. The only difference is we say num1 equals to, want to turn this into the integer, and I say num1 divided by num2. Saying otherwise, we just want to return num1. Okay. So here is the eventual look of our pass term function here. Okay, now let's try to see if this still compiles and runs. Expected literal, it's statement 32. No, there's just an error in num1. Shouldn't be a space there. Yeah, now this should be fine, so let's have a look. Yeah, but since we didn't yet call our pass term, the output didn't yet change. So let's now try to evaluate some multiplication and division being involved in the expression. So for instance, just want to, well, actually I can say, yeah, so I just want to replace the line with, let's say 2 multiplied by 2, so like say by 12, so this is 24 divided by 4, and this is going to be 6, right? Okay, and well, token is still remains there, but 86. So I just want to say that result equals to term and line, the address of the I, and then fmt print line result and result itself. Yeah, and also I don't want to print the token anymore, so just scan through. Yeah, if I did everything properly, it now should evaluate the expression, but expected comma. Yeah, we get our result being equal to 6, which is exactly what we've been looking for. So now finally, last but not least, is to implement the actual expression evaluation, which literally will be holding the options like operators like plus and minus. So just copy from line 21 to line 33 to line 15 and line 14, let's say 34. So line 15, I don't need this. Okay, then line 17, we also don't need to scan there. From the line 17 and up to the line, well, let's say 24, we need to substitute the asterisk with the plus. I want to make it globally, and also the same with division. So division to be substituted with minus to do this globally, and yeah, so if token is equal to plus, then scan num2, yeah, and factor should be changed to term as well. So you can also say let's say, yeah, 17 to 24, substitute. So expression doesn't operate on factors, indeed it operates on terms, so factor to be replaced with term. Okay, so if token is equal to plus, then scan through this, num2 is equal to term, whatever goes there, num1 plus num2, otherwise token is equal to minus, the same stuff. Yeah, this essentially should work, so we don't also want the extra line 28. Okay, yeah, let's just make sure this still compiles and runs. Yeah, it does. And now finally, let's add the real expression here. So I can say line equals to, and let's use this like complicated expression involving all the grammar we've been handling without our recursive descent parser, like plus, minus, multiply, divide, and nested parentheses, and also the unary minus as well. So let's just add this one, and the result now 95. So result is going to be equal, not the term this time, but the expression, and line, and pointed to the integer. Okay. And the result of this expression should be minus 30. I've already checked that, but let's actually see if this is really the case. Okay, I just forgot to delete the line. Yeah, 96, delete. Yeah. Yeah, we actually got a wrong result, so let me quickly check what did I do wrong here. Oh yeah, obviously line number 15, I forgot to change the factor to the term. Yeah, now this should work. Yeah, and we got minus 30, which is exactly the result of this expression. So feel free to give this expression evaluate a try. And yeah, so I've been testing this against Python evolve functions, so that no matter how the complicated expression is, it always gives like a good result, the proper result. So yeah, guys, that's it from my side. I really hope that you've enjoyed following this tutorial, and now it gets a little bit more clear in regards to how in particular recursive descent parsing algorithm can be actually implied in code when it comes to evaluating arithmetical expressions. So thanks for watching, and see you later.